Assalamualaikum and have a good day, guys. So I just want to share a topic that we don't really emphasize, but I think this question will come out for the exam because this is one of the questions from radiations and the topic of fundamental of thermal radiation, which is at this topic fundamental of thermal radiations. So this is one of the questions that I think easy, but it will come out for the exam. But actually, we need to understand the basic concept of Wien's displacements law. So we read the questions first. So the spectral emissivity functions of an opaque surface at T equals to 1000 Kelvin is approximated as this. So this is the range from 0 to infinity. From 0 to infinity. And then this is the piecewise function. So here they ask the average emissivity and they ask the rate of radiation emission from the surface. So before we start to get the rate of radiation emissions, it is actually we can know from the equation, which is the general equation for the radiation, which is E equals to emissivity Stefan Boltzmann constant with T to power of 4. So from these questions we already get T and we already get the constants, so we don't have the emissivity, so which is we need to find the average emissivity. So to get the average emissivity, so here we know that T will equals to 1000 Kelvin. So using the Wien displacement law, Wien displacement law, the equation will be lambda 1 T. So lambda 1 will be, it will show here, which is 3 times by 1000, so you get 3000. So we know also here, this is 2, which is we can conclude this, because it is in the range of lambda. So from the black body radiation table, we know that F lambda 1 will be equals to 0.2732, and at which is we get from here, and then next we take the lambda 2 T, which 6 times 1000, so we get 6000, right? So and then from the table we get 0.73782. okay, so where I got the F lambda x, which is F lambda 1 and F lambda 2, just I show before, I got from here lambda T, and then I got F lambda. Okay, so back to the questions, and I got this and this is already settled lah. And then we continue to get the average emissivity, which is the equation, which is emissivity equals to emissivity F lambda 1 plus emissivity 2 F lambda 2 minus F lambda 1 plus emissivity epsilon 3 with 1 minus F lambda 2. F lambda 2. Okay, so we just substitute from here, which is 0.4 times by 0.2732 0.7 times by 0.73782 minus 0.2732 plus with 0.3, 1 minus 0.73782. Oops. And then we get the answer, which is 0.513 for the epsilon. So we already got the average of emissivity of the surface. Okay, so next, which is the main point, the main answer, which is they want the rate radiation emission E equals to epsilon constant Stefan Boltzmann with T power 4. So we just substitute it. 5.67 times 10 minus 8, 1000. Okay, so we press the calculator and then we get the answer to 9096.6 watt per meter square. So change it to kilowatt if you want. So this is the answer for the radiation emission, rate of radiation emission. Yeah. So I think this question is very straightforward. We just need to know where we need to refer the table, as well as which the formula that we need to use. So from this book, I can see that there is a lot of equations that we need to consider. So you need to find the equation and to suit every conditions in every questions carefully. So I think that's the tips for this chapter. So I think that's all for these questions 12-74. Thank you.